So this video is looking at piecewise, or sometimes called hybrid functions. This is just going to be a bit of an extension of your understanding of functions. It's really just an application of the notation, which looks a bit funky at first, but once you've read it, it will start to make sense. So we just want to be able to interpret that notation and sketch the graph of a function that's given to us. So a piecewise function is really just, it's a function that's made up of several smaller relations for given domains. So in this case, our function f of x is given by three separate relations. So when x is less than 0, our relation is going to be negative x minus 1. When it's between 0 and 1, it's 2x minus 1. And when it's bigger than 1, it's 1/2 x plus 1/2. So all we want to do really is just sketch that just piece by piece. That's why a piecewise function, just following the rules for that little subset of the graph. So the easiest way to sketch a piecewise function is really just to work out where the endpoints of your segment are, or certain little points on it, especially when they're straight line relations like this one is. So if we think of negative x minus 1, so when x is less than 0, let's pick a value that's less than 0. So when x is less than 1, so we'll say f of negative 1 is going to be negative x, so negative x is going to be 1 minus 1 is going to be 0. So at negative 1, our value of y, or our value of f of x rather, is going to be 0. So we know we're there. So you could also label this as f of x and x if you wanted to. So we know that it's going to go through that point there. And our end point, effectively, so when x is less than 0, so our end point there is going to be when x is 0. So if we say 0, I realize it can only actually equal 0 at this point in our middle equation, but pretend it can equal 0 for now. So negative 0, which is just 0, minus 1 is going to be negative 1. So that's going to be in there. Now you would just draw a nice straight line between those 2 points. Of course, my ruler won't move. So you just want to draw a nice line. You'd use a ruler, but going from those points off into the beyond. Now our second rule, 2x minus 1, between 0 and 1, we would make sure that we know where the endpoint is when x is 0. So you're going to have 0 minus 1, 2x, 2 times 0 is 0. So it's still going to be at that point, which means our line is going to join up. That's not always going to be the case, so it's always a good idea to check. Our other endpoint is when x is 1. So we go f of 1 is going to be 2 times 1 minus 1, which just gives us 1. So when x is 1, y is, or f of x is going to be 1 rather than y. So that's going to be there. And we know that's our endpoint, so we can just join those straight up. And our third one, when x is bigger than 1, so again, we're going to check where it is if it were equal to 1. You can think of it as 1.000000001. But we're just going to pretend it's 1. That is going to be half times 1 plus a half. Half times 1 is a half, so that's going to give us 1. So good, that's in the same spot. Again, it's going to join up. And we just want to pick a point of x that is bigger, that's still within our little sketch here. So let's pick 2, be nice and easy. So that is going to be a half times 2 plus a half is going to equal 1.5, or 3 over 2. So when x is 1.5, when x is 2, y is going to be 1.5, which is going to be about there-ish. So then that part of our line is going to go up like that, off into the beyond. So that's our piecewise function. You can absolutely have ones that don't join up. So this third part of the line could have been starting up here and going off. That is still a completely valid piecewise function. So it's always a good idea to check your endpoints. Now, if we want to state the range of this, obviously this first function is going to keep going upwards in our y values, and this last one is going to keep going upwards, but nothing is ever going to be less than -1. So our range here is going to be -1 up to infinity. That's piecewise functions.